Hello guys, welcome again to another video of your class 12 mathematics regarding chapter 5, that's your continuity and differentiability. In this video we shall be dealing with derivative of nothing more than your exponential and logarithm function. Okay, the first topic is nothing more than your exponential function. Okay, the definition is given to be: let a be a real number such that a is greater than 1, then the function f of x is equal to a to the power x is called an exponential function. So this one is nothing more than your exponential function. So when a is equal to e, we have the exponential function as f of x is equal to e to the power x. This is called natural exponential function. So that's all about your exponential function. Okay, the next one is nothing more than your logarithmic function. So that's nothing more than your logarithm function. Okay, the logarithm function, it's given to be, again, the same thing: let a be a real number such that a is greater than 1. So if a to the power x is equal to b, we define log a x is equal to b. So what do we call that? Is given to be, we say that log of x to the base a is equal to b. So it will be log of x to the base a is equal to b. That's how we're gonna say it. I hope you're clear with the logarithm function. Okay, under this logarithm function there are some simple formulas, like the first one: log xy is equal to log x plus log y, log x to the power n is equal to n log x, and log x to the base x is equal to 1, and log 1 is equal to 0. Don't forget, okay, log 1 is nothing more than 0. And similarly, log x divided by y is equal to log x minus log y. So multiplication means addition and division means subtraction. And lastly, log of x to the base a is equal to nothing more than 1 divided by log of a to the base x. I hope you're clear. Okay, now after that comes the derivation. So I can say that for the derivation, so we have the first derivation will be d by dx to the power e to the power x. It's nothing more than e to the power x. Okay, then the next one, I can say d by dx log x is nothing more than your 1 by x. Then next again, d by dx of a to the power x is nothing more than a to the power x log a, and the last one, d by dx of log x to the base a is equal to 1 by x log a. So these are the 4 derivatives that I have known. So let's begin the exercise. Alright, exercise 5.4. The question is given to be: differentiate the following with respect to x. That's why I have made an underline over there. And question number 1 is given to be e to the power x divided by x. So let me just say let y is equal to e to the power x divided by sin x. Then differentiating both with respect to x, we get, so if I differentiate both with respect to x, I'll get here dy by dx is equal to d by dx of e to the power x divided by sin x. Now if you can look over here inside the bracket, I got here u divided by v. That means I have to use which rule? I have to use nothing more than your quotient rule. So if I happen to use the quotient rule, the answer would be nothing more than e to the power x d by dx of sin x minus sin x d by dx of e to the power x divided by your sin square x. So the next line will be e to the power x. So d by dx of sin x is your cos x minus sin x. So d by dx of e to the power x is nothing more than e to the power x divided by sin square x. Now if you can see in the numerator, I've got e to the power x common, so I'm going to take that. So e to the power x, so the answer will be cos x minus sin x divided by your sin square x. So that's all about your question number 1. Alright, yeah, question number 2 happens to be e to the power sin inverse x. So again the same thing, let y is equal to e to the power sin inverse x. So if I differentiate both sides with respect to x, I'll get here dy by dx is equal to d by dx of e to the power sin inverse x. Now consider this whole thing to be your x. Okay, so d by dx of e to the power x is e to the power x. But is this x? No, right? So differentiate once again. hope you're clear. So that the next step would be e to power sine inverse x. Now d by dx of sine inverse x is how much? 1 divided by root over of 1 minus x squared. So in short, I got your dy by dx to be e to power sine inverse x divided by root over of 1 minus x squared. Alright, let me jump to question number 5. Your question number 5 is given to be log cos of e to power x. So same thing, let y is equal to log cos e to power x. So if I differentiate, I'll get here dy by dx is equal to d by dx of log cos e to power x. The first thing you have to do is I have to consider what I have to consider. I have to consider this one to be your x. Yes or no? Which we have been doing that. So d by dx of log x is how much? 1 by x. But is this x? No. So I have to differentiate once again. Okay. You can use chain rule also. This is the same thing as a chain rule, but chain rule will be a little bit complicated. Okay. So I got this one. So 1 by cos e to power x. Now d by dx of cos x. Now consider this one to be your x. D by dx of cos x is how much? Minus sin x. But same thing, is this x? No, right? So I have to differentiate once again. So that will be minus, so sorry, sin by cos is how much? 10. So I'll get here minus 10 e to power x into d by dx of e to power x is how much? E to power x. So that's your dy by dx. So that's all about your question number 5. Again, your question number 6 happens to be this one. So I can say that let y is equal to e to power x plus e to power x squared is given dot dot dot. That means there are some elements. I got here from x squared till x to the power 5. That means the next term will always be cube 4, last term 5. Now again the same thing, I have to differentiate both sides. So d by dx equal to d by dx of e to power x plus x cube plus e to the power x to the power 4 plus e to the power x to the power 5. I hope you're clear. So if I do that, I'll get here d by dx of e to the power x is how much? E to the power x. Now next term again, d by dx of e to the power x squared is how much? E to the power x squared. But this is not x, so I have to differentiate once again. In a similar manner, consider this one to be x. So d by dx of e to the power x is e to the power x, but this is not x. That means I have to differentiate once again. And x to the power 4 d by dx of x to the power 4 plus e to the power x to the power 5 d by dx of x to the power 5. I guess you're clear. So that the next term would be nothing more than e to the power x plus e to the power x squared. So d by dx of x squared is how much? 2x e to the power x cubed. D by dx of x cubed is 3x squared plus e to the power x to the power 4. So d by dx of x to the power 4 is 4x cubed. Lastly, e to the power x 5. So d by dx of x to the power 5 is how much? 5x to the power 4. So let me just make it into a very x to the power, that should be 4. So let me just make it into a very nice term. So that will be nothing more than e to the power x plus 2x e to the power x squared plus 3x squared e to the power x cubed plus 4x cubed e to the power x to the power 4 plus 5x to the power 4 e to the power x to the power 5. So that's how much I got here, dy by dx. Alright, your question number 8 is given to be log of log x, x greater than 1. Again here, the same thing. So let y is equal to log of log x. So if I differentiate both sides, I'll get here dy by dx is equal to d by dx of log x. I have to consider this one under bracket to be your x. So d by dx of log x is how much? 1 by log x. But is this x? No, right? So I have to differentiate once again 1 by dx of log x. I hope you're clear. I'm going to repeat once again. I consider this one to be your x. So d by dx of log x is how much? 1 by x. This came down, but this is not x. I have to differentiate once again. So it will be 1 by log x. Now d by dx of log x is how much? 1 by x. So the answer will be 1 by x log x. So that's all about your question number 8.